before we start solving a Trigo equation, we want to have a tool that will help us to determine where are the possible angle x. That means in which quadrant the angle x can fall in, and we want to find some kind of ready formulas for us to use to represent this angle that falls in such a quadrant. So this tool is butterfly diagram. For x that is rotated in anti-clockwise direction for one full cycle, meaning from 0 degree to 360 degree, or in radian from 0 to 2 pi. So based on our ASTC, we understand that the angle can possibly fall into either quadrant 1, 2, 3, or 4. So if I rotate the angle in anti-clockwise direction and stop at this position, so I will draw out a right angle triangle in such a way. So this is actually my angle x. Now in this right angle triangle, I use this acute angle alpha to help me visualize the opposite and the adjacent side. So this one tells me that in fact my angle x and my reference angle alpha is the same. Now if my angle x rotate all the way to this position, which is in the second quadrant, and after drawing this right angle triangle, my small acute angle alpha is here. That will help me to see the opposite and adjacent side. So my x is here. So what we actually notice is, after rotating x and stop here, if I let x plus alpha, it will give me half a cycle. Half cycle is equivalent to 180 degree, or in radians is pi. So if I rewrite this formula and make x as a subject, I will get x equals to 180 degree minus alpha, or pi minus alpha. Now if my angle is rotated all the way to third quadrant, that is over here. So this is actually the acute angle alpha that will help me to see the opposite and adjacent side. And this is how big my angle x is. So what we notice that since it falls into the third quadrant, this angle is already more than half a circle, right? So it's bigger than 180 degree. So how much more? Well, from 180 degree, I rotate alpha more. That is actually how I get my x. So therefore, x equals to 180 degree plus alpha, or pi plus alpha. Now if I actually rotate the angle into the fourth quadrant, which is stop over here. So this is actually my small acute angle alpha that will help me to see opposite and adjacent side. So what we notice is, in the fourth quadrant, from x, if you continue rotate alpha more, it will give me one full circle. So it means that x plus alpha is our 360 degree, or in radian is 2 pi, right? That's actually one full circle. So if I make x as a subject, it becomes 360 degree minus alpha, or 2 pi minus alpha. So this is our first butterfly diagram. That is to represent our x rotate in anti-clockwise direction for one full cycle. What if the range is changed? That is, if the range require x to be from minus 180 degree to positive 180 degree, or in radian, from minus pi to pi. So we will need a different butterfly diagram. So notice that from minus 180 to 180, of course, it is also from lower half all the way to positive half. That is actually one way to do, right? But rotate an angle in anti-clockwise direction will only give us positive angle. Which means if I want to have 0 degree to 180 degree, I will continue my rotation in anti-clockwise direction. So this will cover my quadrant 1 and 2. If I want to have a negative 180 degree, I must rotate the angle in clockwise. Right? So let's start. If I rotate the angle anti-clockwise from 0 to this position, this is my x. That's my quadrant 1. So same thing. I use this little acute angle alpha to help me visualize my opposite and adjacent side. So this one tells me x equals to alpha. If I continue the rotation in the same direction, this will give me x stop over here. And this is my alpha. And this one again, as we know, x plus alpha should equals to 180 degree or pi. So if I make x as a subject, it's equals to 180 degree minus alpha or pi minus alpha. So notice that this first part is the same as our first butterfly diagram. Now let's pay attention to these two lower half plane. So in order for me to have a negative angle, I must change my rotation direction. So if I rotate the angle clockwise in this way, if this is actually my angle x, so this is still my small acute positive angle alpha that help me to visualize the opposite and adjacent side in a triangle. Notice that if I ignore the rotation direction, actually x equals to alpha. But alpha is a positive angle. X rotate in the clockwise, meaning it's negative. And therefore, I must write x equals to negative alpha. In order for me to come to the third quadrant, I will continue my rotation in clockwise direction because they want negative angle, which is come to here. Okay, so this is x. And again, this is my small alpha, positive acute angle. Help me to visualize the opposite and adjacent side. And so once again, we notice that if I use x continue plus an alpha, that will give me half rotation, which is x plus alpha should equals to 180 degree or pi. Okay, but be careful, huh? When we say that, we ignore the rotation direction. So I use the magnitude to try to show this idea. So ignore the rotation direction. And therefore, if I want to find x, isn't that it is 180 degree minus alpha or pi minus alpha? Okay? This is how big the x is regardless of the direction. This is positive answer. But we rotate the angle in clockwise, meaning x must be negative. So if I remove the magnitude and to show people it is a negative angle, I must write x equals to negative bracket 180 degree minus alpha or negative bracket pi minus alpha. Open the brackets, it gave me minus 180 plus alpha or minus pi plus alpha. And if you want to write the positive term first, I can rewrite it as x equals to alpha minus 180 degree or alpha minus pi. So this is for our third quadrant. So this is our third butterfly. Sorry, this is our second butterfly diagram. Okay, let's solve this Trigo equation. The step number 1 that we need to do is to make the Trigo sign ratio as subject. So to do this, we will actually plus 1 on both sides. So that will give us sine x equals to 1. Then we divide 2 on both sides. Therefore, sine x equals to half. Now, before we start solving, make sure that the angle x in the equation will match with the angle x that's given in the range. Alright, otherwise we will have to adjust the range. So for this question, we don't really need to do this. Now the step number 2 is to find the reference angle. We will call this as alpha. Now, reference angle alpha is acute. So, all the ratios for alpha must be positive. So what does that really mean? That means if I want to find alpha, I will write it out as sine inverse. And then in this bracket, I will substitute the ratio, but it must be positive half. So by pressing our calculator, it will give us an answer as 30 degrees. Okay, of course over here, you make sure that your calculator angle measurement mode must be in degree mode to match with this given range. Okay, once we find this answer, we will need to determine where are the angle x. Okay, meaning we use the ASTC to determine the quadrant. So based on our understanding, ASTC tells us for sine ratio to be positive, it will be in quadrant 1 and quadrant 2. So this is actually the two answers that we are going to look for. And to find the answer, we will need to make use of our butterfly. So we will use our butterfly diagram . Okay, to find the expression for x. So according to butterfly, in the first half, right? So this is actually what we know. If this is actually where x stop, angle alpha is here. So x equals to alpha. That's in our quadrant 1. And if it's in the second quadrant, this is our angle alpha, and this is where the x stop. So x equals to 180 degree minus alpha. So this is actually what we mean. Use our butterfly to determine x. So x equals to alpha, 180 degree minus alpha. Now substitute what we found out, which is 30 degree. 180 degree minus 30 degree. So the two answers that we found is 30 degree and 150 degree. Okay, let's solve this particular example. Now, in our example, cosine x is already the subject, so therefore, we don't have to make it a subject anymore. Just check the angle x and the angle in the given range match. Therefore, there's also nothing I need to adjust for the range. The only thing I need to pay attention is the angle now is measured in radians. So check the calculator, make sure it's in the radian mode. Okay, once we have all these done, let's go and find alpha. Alpha equals to cosine inverse. Remember, we must substitute only the positive ratio, that is positive 0.5. So from the calculator, we know that this answer equals to pi over 3. Okay, now ASTC tells us for cosine ratio to be negative now, okay, because the question say it is negative half. So cosine ratio to be negative, x falls in second quadrant and the third quadrant. So our butterfly shows us in these two quadrants. This is the x in second quadrant. It's equals to pi minus alpha. And here is actually x in the third quadrant, that is pi plus alpha. So therefore, x equals to pi minus alpha, pi plus alpha are my two answers, which is pi minus pi over 3 and pi plus pi over 3. So this will give me 2 pi over 3 or 4 pi over 3.